Hello friends, this video on integrals part 16 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 15. Here also if you see, this is 1 plus cos x square and also in the denominator. So we always try to take that value as 3 which is in the denominator or to the power of some number, right? So we'll take 1 plus cos x as t and we'll try to see if this helps. If not, we'll try something else. Right? Why I'm trying this because this guy is to the power 2 and also it is in the denominator. So this is one good option for me. So with this I get minus sin x dx is equal to dt. Check if sin x dx is there in the numerator. Yes, it is there. Correct? That means I can write as this guy as nothing but minus dt. Sin x dx is nothing but minus dt. This becomes minus dt. And this becomes 1 plus cos x squared, nothing but t square. So I'll take minus 1 outside dt by t square, and this is nothing but t to the power minus 2 dt. Correct? Minus 1 into, and this will come out to be t to the power minus 2 plus 1 by minus 2 plus 1, and whole thing into minus 1 plus some constant, that you get minus 1 cancel, you get t to the power minus 1, that is 1 by t plus some constant. And what is the 1 by t? T is nothing but 1 plus cos x, 1 plus cos x. And you get this answer. Very simple. Nothing great here. So now just by practice, since we have solved so many questions here, right? We are comfortable in solving the integration question. Now we know which value we should take as t. In this question, just by our past experience, we can say that 1 plus cos x has to be a t. And we found that this was really helpful and we were able to solve this question, right? So the more you practice, the better it is. In this video, I tried to cover almost most of the patterns of the questions. Most of the patterns of the question I've covered, and the question which you'll get will be a similar pattern. If you apply a little bit of brain, you'll be able to solve those kind of questions. Let's take one more example. Here we have x plus 1 into x plus 1 log x squared dx. Again here I can choose x plus 1 also as t, but this is a better option for me. Looks like, why? Because it is to the power 2. So I'll take x plus log x as t. Let's see if this helps, right? So this becomes 1 plus 1 by x dx is equal to dt, or I get x plus 1 by x dx is equal to dt. Now let's see if x plus 1 by x dx is in the question. Yes, I do have x plus 1 into dx, and this guy is dt. Yes, that means I get this guy is dt, and this is x plus log x, nothing but t. So t square, and the whole thing remaining is dt. Correct? So this becomes t cube by 3 plus some constant. What is the value of t? T is nothing but x plus log x. So this becomes x plus log x to the power 3 by 3 plus some constant, and that is the answer. The only crux here was finding what should be equal to t. So here also by our past experience we found that this is equal to t, and when we place this, everything matched and we were able to find a solution. Root 10x sin x cos x dx. Here root 10x is in the to the power 1 by 2, so we can take 10x as t. Let's see if it works or not. If 10x is equal to t, I get sec square x dx as dt. Do I have sec square x component? No, this won't help. Let's try with sin x. If I take sin x is equal to t, I get cos x dx is equal to dt. Do I have cos x dx? No, this won't help. Let me take cos x as t now. If I take cos x as t, I get minus sin x dx is equal to dt. Do I have sin x dx component here? No, not here. So what should we do? So in such question we have tan or sine and cos. What we can do is we can write tan as sine by cos. And let's try to simplify this. So let's do this. Tan becomes sine by cos to the power 1 by 2 into 1 by sine into 1 by cos. Correct? This is, if you solve, this is nothing but this sine and this sine will go off, right? So this will become root sign here. So I'll get root sign here into 1 by cos to the power 3 by 2. Correct? That's what it will get. Cos into cos to the power cos to the power 3 by 2. Now, if you see in this case, if I will multiply divide, in this case, this is not helping me much because root cos is of no use to me actually, because it is cos into root cos. So let's do one thing. Let's divide and multiply with root cos, both sides. So let's say root cos here and root cos here. Correct? Here or here, both same. So this becomes 1 by root tan, and this becomes cos square x, or this is nothing but sec square x into root tan x dx. Now stop. Why stop? Because we know that tan x differentiation is sec square x, right? If you take tan x as t, my sec square x dx is there. So I can now use this. Correct? Because if I take tan x as t, this becomes root t, and sec square x dx becomes dt. So my equation is like this, and this is very simple to solve. This is nothing but t to the power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 plus some constant, that is nothing but root t by 1 by 2 plus constant, that is 2 root t, that is 2 root t is nothing but root tan x plus some constant, and that is my answer. So what we have seen here, when we tried initially using tan x is equal to t, we were not able to use. Then we simplified this further a little bit, because tan x is sin x by cos x. We rearranged this and we got this kind of equation. Here now if I put tan x is equal to t, my equation is very simple, dx by root t. So this is one example where I can't directly put tan x is equal to t, but I simplified this and then I put tan x is equal to t. To solve this question, again we have to find what can I take as t. Let's take the whole thing as t, tan inverse x to the power 4. Why? Because this looks complex to me, sine of this some number. Let's take this guy as t. We can try with x to the power 4 also as t, but because if we try with x to the power 4 as t, this becomes 3x cube. So we get that value also. We can try that also, or we can try this also. Because I'm getting, with this if I take as t, I get 3x to the power cube into 1 plus 1 by x to the power 4 square 8 dx as dt. Correct? And these are something I have, x cube by 1 plus x to the power 8, x cube 1 by x to the power 8 dx, yes I have. So that is nothing but, if you see, x cube by 1 plus x to the power 8 dx is nothing but dt by 3. So my equation will be sine of t dt by 3. So this becomes 1 by plus 1 by 3 into minus cos t plus some constant. Correct? T I can say is nothing but tan inverse x by 4. So this becomes 1 by 3 minus 1 by 3 into cos of tan inverse x to the power 4 plus some constant, and that is my answer. Correct? This is my first approach. Sorry, this is 4x cube, right? This is 4x cube by 1 by 4x cube. Why 4? Because if you differentiate x to the power 4, this is 4x cube. So this is 1 by 4. If I try to solve with the same question in the same different way, I'll do that. I'll show you how to do that. So instead of tan inverse x to the power 4, I'll take x to the power 4 as t. So I'll take x to the power 4 as t. I'll get 4x cube dx as dt. Do I have x cube dx? Yes, I have x cube dx. So this becomes integration of dt by 4 x cube dx into sine of tan inverse t by 1 plus t square, because t is x to the power 4 now. Now again we have to take tan inverse t as m, some more value, because this is again a difficult one. So I'll take tan inverse t as m, so I get 1 plus t square dt is equal to dm. So do I have 1 plus t square dt? Yes, I have 1 plus t square by dt. So this becomes dm by 4 sine of m integral, and that is nothing but, if you see, 1 by 4 sine m dm, correct? And this will come out to be same thing. If you see, right, this is this guy and this guy is exactly same, and if you follow from here, this guy will come minus 4 cos of m plus c, and m is nothing but my tan inverse t, so you'll get minus 1 by 4 cos of tan inverse t plus c. T is nothing but my x to the power 4, so this again you write as this, I'll write here as minus 1 by 4 cos of tan inverse t will become x to the power plus some constant, and that is, if you see, both are same answer, same answer. So you take any approach, you get the same answer. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.